The next type is increasing, decreasing, finding the minimum, the maximum points of the functions. In 2015, for example, the question is: consider the function, determine the interval where f is increasing or decreasing. In this case, it's decreasing. So the first derivative always shows us the intervals of increasing and decreasing. So we have to find the derivative. The derivative of f of x is 1/3 times 3x squared minus 1/2 times 2x minus 2. When we simplify, we get x squared minus x minus 2. And then we have to find the intervals. So we need to find the zeros of this polynomial. So we have to equate this to 0. X squared minus x minus 2 equals 0. The easiest method is finding the discriminant and using the formula for solving the quadratic equation. So x12 is 1 plus minus radical 1 plus 8 over 2. This is equal to 1 plus minus 3 over 2. We have two solutions, 2 and minus 1. Minus 1, 2. And now we have to put plus minus plus. This means where the function is positive and where it's negative. Actually, the derivative function is positive or negative. The easiest method is when we just pick a number between, for example, minus 1 and 2. The easiest number is 0. This number 0, when x is 0, we replace here 0 minus 0 minus 2. We replace in the derivative 0 minus 0 minus 2, it's minus 2. So minus 2, it's a negative number, that's why we put minus here. And they are always plus minus plus minus. Plus, plus. Not always, but many often. Yeah. So this means that the derivative function in this interval is positive, in this interval is negative, in this interval is positive. This means that the primitive function f of x is increasing here, decreasing here, increasing here in this interval. And the question is: determine the interval where f of x is decreasing. The answer is x is less than minus 1 or x is greater than 2. That's it. Question 2014 is the same, but here it's given the derivative function. This means that we are directly here, so we just have to find the zeros. So 2 and 3, and again, if x is 0, minus 3 times 2, it's minus 6, so it's minus here, plus minus. So this means that the function is decreasing, increasing, decreasing, where the interval is decreasing when x is between 2 and 3. That's it. 2013, the question is similar but given by different way. The diagram below shows the graph of the function. So this is f of x. This is f of x. And we know that f of x is increasing from minus infinity to minus 2. It's decreasing from minus 2 to 0, 0, and it's increasing from 0 to 2, and it's decreasing from 2 to infinity. Write down the values of x where the derivative is equal to 0. But if you see the other questions, the derivative is 0 here, for example, at these points, minus 1 and 2. So these points are maximum or minimum. In this case, minus 1 is maximum, 2 is minimum because it's decreasing, increasing. So here, of course, when x is minus 2, we have maximum, here we have minimum, here we have maximum. So when the derivative will be equal to 0, when x is equal to minus 2, when x is equal to 0, when x is equal to 2. In all these 3 points we have maximums, extremums, and give the intervals where the derivative is less than 0. The derivative is less than 0 when the function is decreasing. In this case, see, it's negative, so the function is decreasing. Where the function is decreasing? The function is decreasing if when x is from minus 2 to 0, from -2 to 0, or it's decreasing here from 2 to infinity when x is greater than 2. In 2012, the diagram below shows the graph of the derivative. So this is the derivative, and so what does it show us? The derivative function is above the x-axis from 1 to 0. It's above the x-axis, and it's below the x-axis when x is less than 0. So the derivative of x is greater than 0 if x is greater than 1, and the derivative is less than 0 if x is less than 1. What does it mean? That the function f of x, the primitive function f of x, is, here is written greater than, so it's increasing in this on this interval. F of x is decreasing when x is less than 0. Determine for which value of x the function has an extremum and specify its nature. So x is here, it's 1. F of x is increasing. No, f of x is increasing when it's greater than 1, and it's decreasing when it's less than 1. So 1 is extremum, but what extremum? It's increasing, so it's minimum. This is the nature of the function, of this value. That's it.